Thanks everyone for coming. My name's Ryan Burr. I'm a director of engineering at Signal Advisors. Signal Advisors is a post-Series B fintech company in Detroit, Michigan, but we're a fully remote company. We have employees all over the country. And so what we're really trying to do is solve the retirement crisis in the US. 69% of Americans don't work with a financial advisor today, and only 28% of Americans actually have a financial plan. So it's kind of our goal and our mission to empower independent financial advisors and give them the tools they need to really run an effective practice, help them out operationally through automation and a technology platform where they can essentially manage their business. So one of the ways we're helping financial advisors is through notifications in our platform. So financial advisors, whether they be a shop of 1 or a shop of 20, typically are on the go, out of the office. So these notifications can be really important to them to know what the status of applications are, when they get paid, if something needs, a set of eyes on it to help push through the process. So these notifications can really provide a lot of value to our advisors. So it's really important for us to make sure that every notification we send out has the data that it needs to fill the template to make sure those notifications are high quality and accurate. And so one way we do that, well, a little bit of background. So the React meetup in Detroit, I gave a presentation a couple of months ago on how Signal Advisors builds our email templates notifications with React. So you don't need to know anything about React. This is kind of like a part 2 to that talk. But the main point, one of the points from that talk was us using a library called handlebars.js to essentially interpolate data into our notification templates. So handlebars.js just uses mustache syntax to inject data into the templates. So they have different mechanisms to iterate over arrays, or you can write utility functions and get a lot more value out of that library. So just a little background there. So now that we have a means of injecting data into our templates, what about the developer experience of creating these templates? So how can we be sure that the data we're putting into these templates are accurate and contain the required properties or the correct formatting or whatever we want to define? So this was a big concern for Signal, just given that we want high quality notifications going out. So TypeScript was kind of a perfect fit for that. You can describe the shape of your data very pragmatically. You can define properties as primitives, complex types. You can use extends. There's a whole bunch of TypeScript utilities you can take advantage of to kind of shape your data model however you need to. And so with we're able to take advantage of all of those things, and you can get some real-time feedback from the compiler if you're providing too much data or not enough data in these payloads. So again, TypeScript was great if you're developing in the same repo or if you have access to the type definitions. But really, the TypeScript compiler is a development time tool to give you feedback. But what if we need that data at runtime? What if we need to use these TypeScript interfaces within a REST endpoint where we don't have access to the type definitions or our TypeScript compiler? And so that is kind of the problem that we were trying to solve with kind of our notification architecture. So we have all different services kind of in our infrastructure that post notifications to create a notification to get sent out. And spoiler alert, we store our schemas and our templates in a database. And then our notification service, which we call Raven, kind of gets those templates, gets those schemas, and validates those with the payloads that were sent into the endpoint. Again, so we can validate that we're sending notifications out with the correct data. And so today we're going to be kind of diving into this validation of these payloads with these schemas, how we generate these schemas, and kind of how we manage that development process. So one way we do that is we convert our JSON schemas, or sorry, we convert our TypeScript interfaces to JSON schemas. So JSON schema is just a specification that allows you to annotate and validate JSON data. You can specify different data types. You can nest them to get your desired model. The more complex your data model gets, the larger this JSON structure grows. It quickly becomes unwieldy to manage by hand. And so that's kind of where this library TypeScript JSON schema comes in. So this is a library that allows you to generate these schemas directly from a TypeScript interface, a class, types, kind of whatever you want to feed into it. It'll generate a JSON schema for you, which is much better than managing a JSON file by hand. So where we kind of generate these schemas, we have a separate repository for notification templates, where we kind of define the data model with these TypeScript interfaces. We have our handlebar templates, and then once we're kind of done developing, we have a CI process that compiles the templates, generates the schemas, and then goes and stores those in a database. And again, this is kind of what we're going to be talking about today, is the generating our schemas from TypeScript interfaces. So with that, I'll jump into some live coding examples. So we'll kind of walk through like a basic example of using JSON schemas from TypeScript interfaces and show off some of the capabilities with nested properties, enums, utility types, all of that good stuff. All right, so just a quick kind of overview of this repository we'll be using. It's a pretty bare bones repository. It's got TypeScript. I use TSNode to run some different commands. TypeScript JSON schema, which we just talked about. And then we use a library called AJV for validating JSON schemas against a payload. I figured I should kind of preface this. So some of the examples we'll walk through, I've created some just very basic utilities to generate a schema and then to also validate a schema. So I'll dig into those in a minute. But so the first example, we'll just create a pretty basic interface here. With name and hometown. So I have some npm commands written to build these different examples. So this build example 1, if we look at our package JSON, it's going to just essentially call this example 1 command. This example command is going to take example 1 and generate a schema from it. So diving into what happens when we generate this, or what does that look like? So I've defined a couple environment variables just to know where we're pulling from and then where we want to kind of output these schemas to. This second block here is really telling TypeScript JSON schema what files we want to look at. I'm taking, from our source directory and then our example name .interface, and that's the only file we're compiling, but you can get a whole list of interfaces to generate at a single time. And then once we kind of have our program specified with the files we want, we can execute that. TypeScript JSON schema has a whole bunch of options you can provide it. There's one called no extra props. It'll just remove some extra things within that schema that tell you, I don't know, it's just a bunch of metadata about the schema. But if you want to go play around with those different options and see what they output, definitely encourage that. Next, we're going to kind of extract the schema. So again, right now we're only compiling one interface at a time, but if you had multiple interfaces or types or whatever, there's going to be multiple definitions in this file, so you'll need to kind of parse out which ones you want that way. And then we're just going to write it to a file in our build folder called our example name.schema.json. So let's go ahead and run that build command. Generating schema. All right, so we have one generated here. So if we go into our build folder, we have example 1 schema JSON. So pretty bare bones. We just had our 2 properties, nested within, it's just an object, 2 properties, type string. And you'll notice that both of these are required. So if we were to change one of these properties to optional, let's say I don't have a hometown, so we'll kind of rebuild our schema here. Look at this, and now hometown is no longer a required property. So one other kind of command that I wrote was this validate command. So validate, let me look. Yeah, validate 1. Okay, yeah. So this validate command, we're just going to take a payload. We're not using that interface, so this is kind of simulating, just a raw JSON that's kind of coming in from, like let's say a REST endpoint. And then we're going to try and validate that against one of our schemas. In this case, the first example schema. So npm run validate example 1. So because we made hometown an optional property, we technically don't need this. And then if we were to, provide like a location property instead, that validation is actually gonna give us an error and say, there must not be any additional properties in here. So we can get kind of that real-time validation on that payload coming in. So going on to example 2. So we had kind of the interface from the first example, but we're going to kind of take that one step farther. We'll try and nest this down into, let's say, like a person interface. I think I had already created one here. Yeah, so little prep time ahead. But so now we have a person interface. Our payload is going to be essentially that same contract of name and hometown, just kind of nested within a person property. So we'll build that example here. Take a look at that schema. And again, very similar to what we just had, but now it's kind of nested within a person. Person is required along with name and hometown. And so because we added some description annotations to our properties on the person interface, those will also kind of get populated within our JSON schema. If we wanted to do anything else with that, we can have documentation right alongside our schema. Some other TypeScript features you can take advantage of, the extends interface. So let's say we'll break out this name interface we'll break out this name property into its own interface. So create a new file, name, export interface, name, and then we'll add that there. We'll import this. Oh, maybe not. Okay, we'll manually import that. From name. And there really should be no difference to the schema that was built. So you can kind of really shape your data if you want. You can share properties. I'll get to an example in a minute, but you can really kind of get creative with the way you want to structure your data, and it's be a little object oriented. So one of the things we can again still kind of nest or validate this payload. So if I open up our validate2 command, we have our test payload here. So for example, I'll get rid of that person and use just the flat structure that we had from the first one. So validate example 2. So we're kind of expecting this to break right now. So yep. So must have required property person. So we can put that back, rerun validate, and we should be good to go. So getting into kind of the next example, let's add another interface or another property here called employer. We'll have an employer interface. We can add a comment, where you work. I had already created an employer contract because I like to cheat a little bit. So we'll import that from contracts, employer. And if we look at this employer interface, the employer has a name and a location that they're headquartered at. But because we kind of separated out name into its own interface, we can just extend that one and not kind of repeat ourselves here. So let's try and build that. npm run build example 3. All right, we built our schema here. So forget, did I make, we'll make employer optional. So if we look at our schema here, I can make this a little bigger. So we have our person, and now we have our employer. Employer is not a required property, only person is still, but employer now has location and name, although that description does not make sense for an employer. Yeah, we'll move on. So let's kind of start to add a little more features in here. So if you work for an employer, oops, you might have a title at that employer. So let's say, what are some titles? Software engineer, product manager, and let's say designer. So these are kind of type literals, I think they're called, right? In TypeScript. So it's essentially, it has to be one of these 3 strings, and it has to match it exactly. One other way to do this is specifying an enum, software engineer. We'll take all these down instead of typing ourselves. What do we say? Product manager. And designer. We probably need a name for this. So we can use that enum here. And then let's rebuild our example. And see what that looks like. So now we have an extra property in here called title, and it's got an enum property in here. So any type literals, any enums will kind of be generated into this enum property in the JSON schema, and essentially telling it that it has to be one of these three values. So if we look at validate our example 3. So we can look at our test payload here. So employer was an optional property, but if we specify that employer had a name, Signal Advisors had a location, Detroit, Michigan, and then we had a title, and if I put like director in here and run this validate command, we should get an error since director is not one of those kind of 3 expected values. So value must be equal to one of the allowed values. So we can change that to one of the allowed values. Rerun our validate command, and our test payload has been validated. So getting on to our 4th example. So just, again, kind of building off of that, I think I actually had nested employer into this. You know what? We'll just work off of our third example. Example 3, interface. So we have our employer. One of the other things you might have at an employer is a start date. And so start date, so the way we kind of handle dates is we typically just have strings with like a year, month, date format, or if it's a timestamp, it's ISO format. So one of the things you can do with JSON schema is kind of specify the format that you want to ensure that that data is being validated against. So JSON schema has some quite a robust set of built-in validation utilities, date being one of them, date time. Another one is email, which I can show off in a minute. But so if we have start date as a date format, it should essentially enforce that it is in fact coming over as a date format in our validation. So if we add a start date of, let's say, I don't know, January 1st, that's probably not a great date format. So let's try and build that. Well, first let's build our schema. So let's check out our schema here. So we had a title, we have a start date, and we can see that format came over through as a date. So looking at this, we're going to try and validate this payload with hopefully an incorrect date format. Yep, there we go. So error must match format date. So we can actually put in a correct date format here of year, month, date, try and revalidate that payload, and that should pass. One of the other things, let's see, we had our person interface. People have emails, right? String. Email address, and then at format email. And yeah, actually, let's run and validate that. You know what? Let's add a couple more properties in here first. So name probably should have like a minLength or a maxLength. So they have kind of keywords to format these. So again, minLength we'll say 2, maxLength of, I don't know, 256. So we'll go ahead and build that schema. What was that? Oh shoot, you're right. I do that all the time. I do. That's like my worst typo when I'm typing. All right, so we have our generated schema. Let's pop that open and see what it looks like. What did we add? Oh, email. No, yeah, we added email, so that's a format email, and then we added maxLength, so it has min and max length properties kind of get ported over. So if we go back to our validation payload, we can change this to like, I don't know, S. So we'll try and validate this payload again and kind of get that error again. Must have required property email. I'm missing that too. So let's do Ryan at Signal. All right, so now we're expecting the employer name to kind of throw us an error here. Yeah, must not have fewer than 2 characters. So I'm not going to type out 256 to show you the max length, but that's the right idea. Yeah, email address as well. One of the other things in JSON schema, you can specify a regular expression as a format as well to get really fine-tuned control over how you want your string formatted, or number for that matter. Yeah, but that's kind of the examples I had. So I guess with that, are there any questions?
Yeah, so the minLength and everything, that was, I think, something that I wanted to see, and that's awesome that it already has that. I'm curious, with your workflow, do you define your types, generate your JSON schema? On that slide where you had, I think, the kind of the diagram, the flow, and then you put the JSON schema template to the Raven service. Is that how you do it?
Yeah. So our Raven service, it manages our templates as well.
Yeah.
So that's kind of where we store them.
And then what are the services? I guess my question is, do the services that are pushing that data to the notification service, do they have access to those types that you generated?
No, they don't.
They don't have the TypeScript types.
Yeah. So one example, probably the biggest creator of notifications within our architecture is actually Salesforce. So Salesforce is not a TypeScript, runtime. So that's, it's Apex if you've ever seen it, and they have they have their own type system, but we can't use our TypeScript types in there at all.
Right, because they're sending it through a webhook or something like that to your Raven service?
Yeah, it's just a REST endpoint.
Okay, cool. That was, I think, but you don't get to use it internally.
Right, yeah.
You have to distribute it or something.
Yep, yeah. So we kind of manage our templates and our schemas in their own repository. Once we're done building those, we essentially save those through Raven in a database. And then at runtime, we read from that database. We pull the schema in the template and then kind of validate the payload that was coming in from this post against the schema, the JSON schema that we've saved.
That's cool. And just one other question: do you do versioning at all for the schemas that you put that you update?
I don't believe we got to versioning. So if we do need to make a change, we are kind of very cognizant of any publisher of those notifications, making sure that they're aware of that. If we need to deprecate a property, we'll mark it as optional. So if they are still sending it, and then where it's very kind of by the seat of our pants versioning, not versioning, but
it's like a GraphQL approach where you
slowly
work things out
until
it stops.
Yeah,
stop using it. Yeah.
And what I think where this kind of shines within our infrastructure is that if a service posted a notification and there was one of these validation errors, we have alerting set up in our infrastructure that we get reporting on if somebody is trying to create notifications invalidly.
That's cool.
If that's even a word.
Yeah, I could keep asking questions, but
what informed your decision to go code first and generate the schemas rather than writing the schema and generating the TypeScript interfaces from someone directly writing the JSON schema?
TypeScript, in my opinion, is a super developer-friendly tool to use. JSON is not. So that was kind of the decision there, or that was one of the kind of reasonings for our decision. The other one is we're using TypeScript up and down our stack, front end, back end, not in Salesforce, but so it just felt natural from a developer experience standpoint to continue to use that. But again, so we needed this validation to happen at runtime, and so this Raven service at runtime really doesn't. So in TypeScript interfaces will compile away. They don't really compile to anything. So we needed essentially access to those at runtime. Sorry, did that answer your question?
Yeah.
Okay.
Thank you.
I guess one question I have is. How good is the match between the expressiveness of JSON schema and TypeScript? Are you able to pretty much do what you need to do in terms of validation? by writing TypeScript and compiling it to JSON?
Yeah, we haven't found like a validation that we haven't been able to solve yet. I know regular expressions kind of gives us a lot more flexibility as well, but typically like our data is mostly like making sure, our validation is really making sure that properties exist or don't. That's really, I think, the biggest thing for us. Date formats are probably another big one.
And then I guess one question is sort of like, looking at this package that you're using, what made you decide to use this particular tool versus any others that are maybe out there on the?
From my opinion, the developer experience, like, I don't know, it wasn't too hard. There are a couple other of like JSON schema generators, but this one seemed to work pretty well.
Cool. Thanks.
Did you look into OpenAPI for any of this? Was that like a consideration at any point? I mean, it's not quite the right exact use case for OpenAPI, but you can use the same kind of mechanisms and tooling for validating these responses.
Not that I can't remember. I don't think we ever did. Matt might have an answer as well.
The hard question. Speak into the microphone. Yeah, so we did evaluate OpenAPI, but that matchup proved to be a little bit of a heavy-handed approach. It would have matched up nicely if we invested probably a little bit more time in a tool like Postman to distribute documentation amongst the developers. But I think the big reason that motivated this decision was just being TypeScript first, being able to write these interfaces, throw it away, and really start treating this configuration as data and allowing us to really kind of drive this, multiple levels of validation through TypeScript first, and just have JSON schema be the thing that runs it as kind of configuration as data.
So are you auto-generating documentation from these interfaces too?
No, we're not really doing anything with documentation. If one of the developers of like another microservice that needs to create notifications, I've just been pointing them to like our notification templates repo, where these types are actually defined to kind of look at the shape of the data there. But yeah, we're not publishing like the descriptions of these data models anywhere.
Gotcha.
Someone else, I've got another one real quick. Can you compare this approach to something like Zod or another like runtime validation library?
Not really, no.
Okay.
I haven't heard of Zod before. There was another validation library that I saw, but no, I can't really speak to that.
Can Zod create JSON schema?
Don't know if Zod can create JSON schemas.
But so again, we're kind of using a different library for the generating the schemas versus actually validating them too. So I don't know if that was Zod.
Yeah, I think Zod is more like an AJB.
Okay, gotcha.
Sort of fits in that niche, I think.
Yeah.
I was curious on your notification templates. So you have the key thing, the purpose is, from what I understand, is the handlebars templates need to have the right data. And then you have to have the right types for that data, right?
Yep.
Do you have anything in CI? I know this is kind of like out of scope almost, but like, do you have anything that runs it against the templates and that says like, hey, this template failed because you forgot to add this to the TypeScript type schema?
Yep. Let me pull it up actually. I can just I'll open up our notification templates repo. So so alongside these TypeScript interfaces, we actually have essentially an example payload next to all of these. So this is one notification. We have our MJML template here. Oh, let me close that. We have an MJML template, which is essentially just a very easy way to create emails. That's kind of what my previous talk was mentioning. And then we have this metadata file. So this tells us information about the notification being created. We have our schema here. And so this is kind of where we extend like a base schema, and then we have we're using like all of these TypeScript utilities of like partial picks, to only have data from these shared interfaces that we need. We have validation here. But then right alongside this, we have essentially an example payload with that schema. And we actually have unit tests that will run this example schema run this example payload against the generated schema to make sure that it's correct.
So it runs it against that, and then does it run it against the handlebar or the assumed handlebars template as well to see if it fails? Or no?
Great question. I do not remember if we had tests for our actual. Yeah, it looks like we are actually compiling our templates as well.
Cool, and then it failed to compile. That's cool. Thanks for walking through that.
Yeah.
All right.
Cool, thank you. Oh, and we are hiring if anyone wants to check out our careers page.